Good morning. My students have a reference sheet graphic organizer and we're going to fill it out. Let's learn something new, right triangles and trigonometry. So we have some graphics there with the trigonometric ratios, and they are all based on a reference angle. It's going to be one of the acute angles, and they're going to tell us which one it is. This one's just marked with an arc. Sometimes it'll be a letter, and you'll need to pay attention to which letter. It's going to be the vertex of an angle. First trigonometric ratio is sine, and sine is opposite over hypotenuse. Let's get that filled in. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So you're going to need to know those. But if you're using your reference sheet, that should help out a whole lot. All right, a little Desmo's assistance. We will be using this. In the upper right-hand corner is the little tool, and we need to select that tool because we need to make sure it's in degrees. I think it automatically defaults to radians. We're not going to use radians. You'll get into radians. Probably not Algebra 2, but Pre-Cal and above. But we're going to use degrees, so make sure it's on degrees. Lower left-hand side is the little keyboard, and we need to select that. And this is what comes up. And usually we're using other keys, but now we're going to use the functions. So the trigonometric ratios we're going to use are sine, cosine, tangent. There are actually 6 of them, but we're not going to use the other 3. Same thing when we're doing the inverse trig functions. We are not going to use the bottom 3 there either. The only ones we're going to use are the ones that are not blued out. Okay, round to the nearest tenth for these. We are finding missing sides with trigonometry. So we're looking at a reference angle in example 1, and it's 42 degrees. And x is opposite that, and 25 is the hypotenuse. And opposite and hypotenuse is sine. So sine of the angle, sine of 42 degrees equals x over 25. To get x alone, we're going to multiply both sides by 25. Please put the 25 in first. We're going to put it in Desmos. So you put in 25, you're going to have to select the sign and then put in your 42. And this is what should come up. To the nearest tenth, we have 16.7. Example 2, according to our reference angle of 75 degrees, we have opposite and adjacent, which is tangent. So write your equation. Tangent is 75 is opposite over adjacent, 12 over x. To get x alone, we're going to have to, well, I told you a shortcut before. The tangent 75 and the x can trade places. It takes a few steps of algebra to get there, but just trust me, it works. So x is equal to 12 divided by tangent of 75. We're going to put that in Desmos. We know how to do a fraction. You have to get that tangent function. You just can't type in TAN, okay? And then put in your angle measure. You should get this, and it's about 3.2. Example 3, according to our reference angle of 36 degrees, we have adjacent and hypotenuse, which is cosine. So cosine of the angle, 36 degrees, equals adjacent over hypotenuse, 19 over x. So x is on the bottom again, so it can just trade places with the cosine 36. So x is equal to 19 divided by cosine 36 degrees. Go to Desmos, type that in. And this is what I believe you get. And when you round appropriately, you get 23.5. Example 4. Our reference angle is 53 degrees, and x is opposite that, and 7 is adjacent to that. So we're dealing with tangent. So tangent of the angle, 53 degrees, equals opposite over adjacent, x over 7. All we have to do is multiply both sides by 7. Please put the 7 first. So 7 times tangent 53. Put it in Desmos. Get your answer. Nearest tenth is about 9.3. Now we're going to find missing angles using trigonometry. So now we need two side lengths, and we need to know which angle we're talking about. So our reference angle is now going to be x. And in example 1, 9 is opposite and 20 is adjacent. So we're going to be using tangent. And x is the angle. So tangent x is 9 over 20. And to undo the tangent and to get into that x, we have to do the inverse tangent. And that's one of the functions that we have in the Desmos that I didn't blue out. Let's see. So Desmos, inverse tangent, you're not typing that in, you're getting that function, 9 over 20. You get this, and this is degrees, and it says the nearest tenth of a degree, so 24.2 degrees. Example 2, our angle that we're looking for, x, let's see, that's adjacent, 17 is adjacent, 32 is hypotenuse, that's going to be cosine. So cosine of the angle, we don't know what that is, we're looking for it, that's x, is 17 over 32. Cosine x, we need to undo the cosine. So we have to use the inverse cosine. So inverse cosine 17 over 32, put it in Desmos, and we get about 57.9 degrees. Example 3, according to our angle, that's opposite and adjacent, so we're using tangent. And remember, x is the angle that we're looking for, and we have to undo tangent. So we have to use inverse tangent, and tangent's opposite over adjacent, so we have 13 over 18. Put it in Desmos, and we get this, which is about 35.8 degrees. Example 4, looking for an angle again, we have opposite and hypotenuse, so that's sine. We're looking for the angle, so sine of the angle x is equal to 21 over 28. Undo the sine by using the inverse sine. Remember, you have to get the function. You just can't try to type that in. And it's 21 over 28. You should get this. So our answer is about 48.6 degrees. And that concludes the graphic organizer for right triangle trigonometry.